and welcome to Introduction to Global Navigation Satellite Systems. In this course we are going to discuss about different navigation systems which are there in operation in space. We all are familiar with the initial systems like Global Positioning System GPS of US Navistar, and later on many new systems have been developed. Still few countries are developing their systems, and a lot of augmented systems are also coming. So during this course we will be discussing all those in details. Basically, as you know, that it is for positioning, and this has been important since ages, that one need to know where I am standing on the globe. And the thinking of that I may be lost because of lack of position was always a problem. And then in past like Christopher Columbus, when as per his understanding he said that the earth is round, people laughed on him because this is what the initial assessment was there. But before that some people used to think that earth is like a plate or something. But after his several adventures, investigations, he found that earth is round. Now he also, because when he was doing all this navigations and other things, they used to use the navigation system not like today, which we are having very sophisticated one, the technique which is called the dead reckoning. And dead reckoning basically is to estimate one's current position based on a previously determined one. And this is how they used to navigate in the sea and explore the world. The process basically in this dead reckoning, the process of determining a vessel's approximate position by applying DR, that is dead reckoning, from its last known position, a vector or a series of conservative vectors representing the run has since been made. And this is how the navigation in the sea started. And later on some equipment also started coming, and then finally we are having now these satellite based navigation systems. So this is how that dead reckoning used to be used, that if I had west from a known location at 10 km per hour, then in 2 hours I should be in the west for covering 20 km starting from my point. So one need to note down the speed and time, and by which then vector used to be drawn, and this is how the position used to be estimated. Now this word which is being used here, or the term, is estimation, because even the navigation systems which are satellite based navigation system, there also we say that the position estimation. And this is how the positions are estimated, whether with the old system of dead reckoning or new systems like this. And as I have mentioned that this is an important question, where am I? All the time, many times it is required, and this question which is very simple sometimes can be a matter of life and death as well. So this if somebody is flying, then it is very, very important. A quick assessment of this location estimation is very much required. Somebody is in distress or lost somewhere, maybe on glaciers or some other dense forest, then they also require the position. So the position has always been important to know, where am I on the earth? This question was expected every time. Now if we go in this that there are various technologies are coming for navigation, and which are all space based technologies which I am talking, except with some ground-based augmentation systems are also there, which we will be also discussing. You are familiar with the very common word which you use, the GPS, that is Global Positioning System, which is basically US developed first this technology as in name of Navistar, or before that SDI, Strategic Defense Initiative, which was a part of a star war between USA and former Soviet Union. But GPS is one of the systems of GNSS. So a new term which we should be using rather than solely GPS is the GNSS, because GNSS includes GPS and other systems like Baidu of China, Galileo of Europe, or GLONASS of Russia, and Indian systems has also come. So if a same device, if it is capable of receiving signals in multiple channels, then the same receiver can receive signals from various such navigation systems. And of course, if your device is capable of receiving signals from various navigation systems, then this position estimation is going to be very accurate. If we take the data only from one navigation system, say for example GPS, that we may not get very good position estimation. So now we are, the devices are there even in a standard smartphones, we are finding that the receiver which is inbuilt in the smartphone are also capable of receiving signals not only from GPS but other navigation systems as well. So it is a better nowadays for navigation we should use word GNSS rather than GPS, because now it is no more only GPS. And as we know that these satellites are orbiting around the earth, and they transmit the data, and our receivers basically calculate the or estimate the position. So that we will be also discussing in later part of this lecture or in other lectures also. As we have been discussing that the question is the where you are and where you are going to is probably one of the man's oldest pastime. Since ages we have been always looking answers to these questions, and we want answer of these questions, that where am I going or heading, very quickly. And that is why we would like to have not only quickly but also the position estimation has to be very accurate. If there are areas where we are having landmarks, so we can locate ourselves rather relatively easily. But if there are areas like if somebody is in a desert area or in some dense forest area where we don't see the landmarks, then the position is required, very much required, and it is hard to estimate without using satellite based systems. So that is what it is very important that if landmarks are there, fine. Otherwise dead reckoning, as mentioned, dead reckoning was more being used earlier in the sea navigation, and then of course using the modern systems, now things have completely changed. There were some other methods like celestial method which was complicated, only works in the night, which was based on the basically stars, but if you are having clouds then one had a lot of problems with that one. And then a system came also is the Omega, which was a radio direction beacons, but again in an open sea, if you don't have the signals from these beacons, then again position estimation was very difficult. So in past like earlier, people started developing new methods of estimations, but they were not as accurate and not available all the time. So people has always been looking a navigation solution or location position estimation solution which should be available for all parts of the world, day and night, in all weather conditions. And these modern navigation systems which we are going to discuss in this course are capable of providing signals or around the clock in all weather conditions. After Omega, this LORAN also, which was there, but accuracy was variable, and it was affected because of geographic situation, and these were vulnerable from jam and other disturbances also. So this is long range navigation or ELORAN. Later on the system came ELORAN, but again the SatNav, basically a satellite based navigation, and this has completely changed the scenario of position estimation, and which is based on the low frequency Doppler measurements, and it is so sensitive that a small changes in the receiver's position can also be detected. And the satellites sends pulse or signals every second, so your position can be estimated very quickly and very accurately. So these satellite based navigation system is now very popular, and this is what the GNSS is, because many such systems are available at global level, and that is why we use the word global navigation satellite system. Now I have used a term Doppler, so very quickly I will go through these few terms. That the Doppler is basically change in frequency of sound, light or other wave caused by movement of its source relative to observer. And we know as in the simple physics as Doppler effect, that if a vehicle is coming towards you, then the noise of or sound of the siren is going to be different. If it is going away, then it is going to be different, and it is due to the Doppler effect. So the the background about the navigation, the background is of course the fundamentals of physics, and there is another term which will be used is theoretical Doppler, that is the expected Doppler frequency based on satellite's motion relative to receiver. Why? Because these satellites are all the time or moving in their designed orbits. So you yourself or receiver might be moving, and the same time satellites are also moving, and therefore some estimations are done, and that is through this theoretical Doppler. So this is computed using satellite coordinates and velocity, at what speed the satellite is moving. Most of the time they are moving at a constant speed, but sometimes there might be some variations. And receiver coordinates, that is what, if I am holding receiver, then my position or receiver's position, and velocity, if I am having a receiver and moving like I have fitted in a car, then the velocity will also play a very important role. And based on this movement, the speed or my velocity can also be estimated very accurately. There is another term which is also used, is apparent Doppler, which is same as theoretical Doppler of satellite above, with clock drift correction added. Because as we will discuss in detail, but initially at this stage I can say that all these satellites are having synchronized atomic clocks. So that because basically in these systems, as we will learn in near future, that when they sends the signal, these signals are time and date stamped, and when it reaches, then the delay time is basically, these are ranging devices. So the time taken to reach to the receiver will give you the distance. So this is how the importance of time, because you are getting signals from various satellites to estimate the position, and therefore all these satellites should have the same timing, and that is why I have used word synchronized atomic clocks they are having, and they are used. Another term which we will be using is a instantaneous carrier, that is Doppler frequency measured at receiver or at that epoch. And epoch is strictly or a specific point in time, typically when an observation is made. So because these systems, these GNSS systems are all the time transmitting the data, and whenever receivers are on, they can receive signals and estimate the position. So worldwide position and time determination system, basically that includes one or more satellites constellation, aircraft receivers and systems, integrity monitoring, augmented as necessary to support the required navigation performance of the intended operation. This is a current definition. It might change in future because new systems are coming, new augmentations are coming, and new concepts are also coming, which we will be discussing also in this course. So basically when we use the word global, that means these positioning systems should be available for any part of the globe. But now, though we are using word global, but people have also developed, or some countries have also developed regional navigation systems like Galileo of European Space Agency, which is a regional systems. Our this NAVIC or IRNSS, which is Indian navigation system, which is also a regional one. It is not global, because these systems have been designed to focus only in the like an Indian system has been designed to focus only in the Indian subcontinent or in little bit in neighboring countries. So though still we will there are global systems are there like Navistar, which is GPS, GLONASS, which is Russian, and Baidu, which is Chinese, also global. So, but in this we are including regional. In our discussion also we will be including regional as well as global navigation, and all these are satellite based. And in order to improve further the accuracy, some ground based augmentation systems are also have been developed, are being used, and some we will be discussing. Space based augmentations are also possible, and ground based. Ground based Indian example is Gagan is there, or SBAS technology is also there. So that will also fit here. So if I again go through the definition of GNSS, that is Global Navigation Satellite System, a worldwide position and time determination system that includes one or more satellites constellation. At least now our receivers, a ordinary receiver inside a smart mobile can receive signals from 3-4 constellations. Like if I go outside of this room and switch on my mobile and some app which can access the data through these constellations, satellite constellation, then I will be getting signals from, of course, from GPS, that is Navistar. I will be getting signals from GLONASS, that is Russian and Chinese. And one SBAS signals are also we are getting, which is through the geostationary satellites. So multiple systems are there, they are possible, they are being used to estimate the position. Aircraft receivers also, they use all these navigation system. All modern aircrafts nowadays are fitted with the GNSS navigation systems, and a very accurate positioning is being done. System integrity monitoring, even in the aircrafts, sometimes if you travel you will find that they display the position of where your aircraft is flying, and in the background you might be having Google map or some other satellite image. So that the position of your aircraft, which is live or it is getting updated every second, is coming from all these navigation system. So it is not necessary that you will get position if you are flying over India, because these are global. So any part of the world you go, you will get the signal. And system integrity monitoring, because whoever develops these systems, they have to maintain the integrity of these systems. So they keep monitoring, and if there are, because after all the satellites are orbiting objects in the space. So sometimes they drift from their designed orbit, so they have to be brought back on the designed orbit, and this is all done through the monitoring and other operations, which a general public or simple users like us, we need not to bother, but those who are maintaining such systems, they have to bother about the integrity, and they monitor and maintain the integrity of such systems. Augmentation, as I have already mentioned, satellite based augmentation like SBAS and others, or ground-based augmentations like Gagan, or some in different countries are having, which we will be also seeing. And basically the intended operation here is position estimation. So what basically has happened, the most significant changes which has occurred in this navigation based, as I mentioned that the first time, because if we go in the background of developments of such navigation system, as like remote sensing is started in the Second World War, and people thought that use this technology to defeat the enemy. And so the GPS or this GLONASS, they were also basically of Cold War between US and former Soviet Union. Both were developing simultaneously these navigation systems to put on the missiles so that they can these missiles can hit the target very accurately, for which they wanted to have some navigation systems. And these two countries developed one. US developed this GPS or Navistar under the program of SDI, and parallelly Russians also developed later on. They too brought to the civilian use as US did. So in 1973 this development started in US, and then early applications were basically these were initially given like in the Iraq-Kuwait war. First time US Army people in the year 1991 they started using these GPS receivers, and later these were released or the permissions were given to the civilians. So people have started using for surveying and mapping, though their size and capabilities and accuracy as compared to today was very, very poor, but this is how the technology started and developed. Now many commercial operators are there, so they are using these navigation devices even in cars now also through mobiles, smartphones, or navigation fitteds in our car. So we can use these. Of course, aircraft started using first, then trains, automobiles, and in the background you are having the map, so you know where exactly on you are, and if you are driving, you know exactly at what speed you are driving. And then once you are having this location and updated location which is being updated every second, in the background you are having a GIS map, then lot many things or lot many informations can come to you. So that we will be also discussing later on. People use also or in the field as a geologist or civil engineers, we can use handheld GPS or GNSS devices, including now smart mobiles, and can get our position or the answer where am I very quickly in just a few seconds, and with the accuracy of these handheld receivers maybe in few meters. So 2-3 meters nowadays with that accuracy it is possible if you are in an open area. People have also started using in farming, in agriculture, how to use these farming machinery for very efficiently for plowing, seeding, fertilizing and harvesting. So that this entire process where the one agricultural plot is very large, maybe of 100 acre or 200 acre, where it is difficult for farmers to do such work. So if they can employ this GPS or positioning system, automatically guided machineries can be used there. And as new systems by different countries are being developed, as more accuracy we are getting, accuracy estimations or position estimations we are getting, more new applications are also coming. So those will keep coming. Many of these we will be discussing in due course of this course. It is necessary to augment GNSS technology with other systems, maybe ground based, maybe satellite based and others. And of course, people are trying to use to improve basically position and as quickly as possible. So two things are there, because there were one technology which is also came, which is differential GPS and post processing. That means you do the field survey, later on you come in the lab and then do the post processing, then only you will know the accurate position. So rather than knowing later on, everyone wants that when I am in the field or outside, I would like to know exactly where am I as accurately as possible, as quickly as possible. So that is why all these new technologies are getting integrated in this GNSS technology. As we know that there are constellations. Constellation means here the network of basically satellites, all are moving in space, and they are basically enveloping the earth at a very far distance. And as also mentioned that these satellites broadcast their the signals, and this signal is basically contains the ID of the satellite and where am I, the position of the satellite, and at what time the signal is being dispatched. And once it is received by a receiver, then the position estimation is done, but it is not based on just signal from one satellite. The signal, the receiver should receive signal at least minimum for horizontal positioning at least from 3 satellites, and for if we want the jet position also, then from 4 satellites at the same time. Then only these X, Y and Z positioning can be estimated. So these receivers basically they are having a small computer inside, so they process these signals which are coming from satellites every second getting updated, and after processing you get the location estimation, you get the speed if the receiver is moving, and time. Time is also important, and time is also the time which is coming through these satellites. As I have mentioned, they are having atomic clocks, very accurate. So only that there are some applications where people are using only time from these constellations. So that is another very interesting thing which we will be also discussing. It is not only that we get the position only on the surface of the earth, but we can get position in space as well. Like this aviation sector, they are using, though they are not in space, they are quite near to earth, but if you go in deep in space, probably you can get signals there also, and position estimations is possible. And a lot of development, as I have already mentioned, that you are having initially the GPS came, and then Galileo, and then GLONASS, and then Vaidoo, IRNSS, which is our Indian system. It has been renamed as NAVIC, QZSS, which is a Japanese system. So here GPS is truly global system, Galileo is completely regional system, GLONASS is a global system, Vaidoo is a global system, IRNSS, QZSS, all are these are last two are the regional systems. So there are all these navigation systems are there in some parts of the earth, like if I am located in India, I may not be getting signal from Galileo, which we don't get, I have checked, and we get the signals from like of course GPS, Navistar GPS, we get the signal from GLONASS, we get the signal from Vaidoo. IRNSS, in future we will be getting signals. And in addition to this, our receivers, which is a single frequency, if we go for dual frequency, we can get more signals from other augmentation systems, but even a single frequency receiver is capable of receiving signals from like Vaidoo, GPS, GLONASS and SBAS, which is coming from geostationary satellite. Now these satellites or these constellations are at different distance in the space. Their constellation, their design, orbits are completely different. But still our receiver can receive signals. Only thing now we require more smart programs within our receivers so that they can process the data and estimate the position as accurately as possible. So like GPS or Navistar, which is of US, having a standard constellation is 31 satellites. GLONASS, which is Russian, is having constellation of 24 satellites. Galileo European, which is having 30 satellites. But remember, it's a regional system. Baidu, which is Chinese, the standard constellation will have 35 satellites. IRNSS, again regional system, will have the 7 satellites, because most of these satellites are going to be geostationary or geosynchronous. So because this is not a global one. If you want to cover or provide the signals for the entire global community, then you have to have more number of satellites. So India has decided to focus only for the regional system. QZSS, which is Japan one, the only 3 satellites, because Japan being a small country, and they thought that for them it is more than sufficient. Of course, the signals from other navigation systems like GPS or GLONASS or Baidu are also available. So position estimation using these 3 global systems plus 1 regional systems plus SBAS, one can get a very good positioning. Gagan, as I have mentioned, which is Indian system, which is it was developed when we didn't have this IRNSS or Baidu signals and other things. So Gagan was basically to augment the GPS signals, and which was based on the ground for improving navigations all along the coastal lines. So that was also there. Now all these satellite system consist basically 3 components. One is of course a space component, and then another one is this your control component or control segment, and then user segment. So these GPS is having 31 satellites, and all these are in different orbits at a very 20,200 kilometer deep in space. So these is the entire this network or constellation of these satellites, we put them as a space segment because they are in space. Now as also mentioned that in order to maintain the integrity of these satellites, the monitoring has to be done regularly, and if there are some problems, then either a satellite has to be replaced, or if a repair required or correction in the orbits are required, that can be done through the ground. As you can see here that there all these systems, if we take the example here say for the GPS, then there is a master control station which controls everything. Then there are base stations, and there are many monitoring stations all spread all over the world, being a global positioning system. And then a last segment where we fall basically, which is user segment. So we might be using a handheld device, handheld receiver, or maybe using nowadays a smartphone, or maybe it is fitted in our vehicle, car, or maybe in aircraft. All these who are using, they don't have to do, or they don't have to transmit anything. They don't have to control, manage these systems. They are just using it, then that is the user segment. So a space segment, control segment, and user segment. 3 components or 3 segments of a GNSS system. Each GNSS system will have in the similar way. Now as said that the space segment, which is purely satellites orbiting in different, this is the example from GPS, then ground stations are there, some are monitoring stations, some are controlling stations, master station, and then of course finally you are having users. A space segment basically like if we take the example of GPS, 20,200 kilometer, all these satellites are orbiting in different orbits, and each these navigation systems have its own constellation because they have been the purpose are different, some are regional, some are global. So that is why each are having their unique constellation arranged in orbits to provide desired coverage, whether global or that one. Now control segment which comprises a ground-based network of master control station, data uploading stations and monitoring station. Data uploading, because our receivers are just receivers, they cannot upload. And why uploading? Because if corrections are required in the satellite orbits or other things, or maybe corrections in the clock or some other, then there has to be one master control station from where they can upload the data to the satellites. And monitoring stations are spread all over the world for global systems. And each GNSS system, you will have a master control and then which adjusts the satellite parameters, basically the orbit drifting, and on-board high precision clocks necessary to maintain the accuracy. And monitor stations usually installed over a broad geographic area, maybe in different parts of the world, monitoring satellite signals, status, strength, quality, and then transmitting that information to the master control station for any correction if it is required. So this is how this control segment works. And user segments where we are, which basically consists of receiver which receives the signals, process the data and estimate the position. So this is there, and user segment basically will have a receiver, a receiving system, and these are being used now by various people for various purposes, and for leisure, for traveling, for navigation, and for disasters. In case of disasters and other things, all these devices are being used. Okay, so now very briefly I will go through the history of satellite navigation. And some part we have already touched, but that was like Dead Reckoning and others. But basically this current satellite navigation history, which if we look, then it basically started somewhere in 1960, and when these satellites started being launched, Sputnik and Explorer were launched, and preliminary systems, Transit, which in Transit, the name was of that system was, which became operational in 1964, basically developed for nuclear submarines, and then polar orbiting satellites, which exploited this basically measuring Doppler, and they were all focusing initially for war or related those army military related things, but later on they became available to normal users or in civilian domain. And Timation satellites 1967-69 used first on-board precise clock for passing ranging. So this is not in one day this satellite navigation technology has developed. As you can see that since 1960 things started developing, and even in 67-69 these clocks, atomic clocks, we started going on the satellites, and people developed experience, and now current navigation systems are. Full scale GPS development began basically in 1973 with this Navistar, and then it continues, and not only now US but many other countries, as we have mentioned, are there. Initially first satellite vehicles, SB stands for. So first 4 vehicles were launched in 1978, and then the full operational capability were developed in April 1995, when the constellation had 31 satellites in case of GPS. Now, as mentioned that GPS was a part of a strategic defense initiative, or people also call as a Star War, which was between these two then enemy countries, US and former Soviet Union, and basically they wanted to hit each other targets with high precision, and for that all this started developing. Now when initially the GPS came in the civilian domain, there used to be a problem about the selective availability. That means that the signals were encrypted so that civilians do not get a high accuracy, whereas US Army people with their receiver used to get accuracy. But later on that has also changed. So as mentioned, that GPS, the current GPS is a product of SDI or Starbars, which was a dream project of then President of US Ronald Reagan. Now if you are having background of civil engineering or earth sciences or geology, you would know that how position is determined by these navigation systems. Basically this concept comes from this back bearing concept or forward back bearing concept, where we used to have a compass and objects which we are seeing on the ground, and same time we used to identify these objects on our topo sheets as well. So when you take a bearing from compass of an object which you are seeing on the ground, then you draw this bearing line and then take the bearing from another object and draw again bearing or this line. And with the line, these two lines, where they will cut the back bearing, basically by back bearing, because we are looking towards the object and writing down the other direction, that is the direction towards us. That is why it is called back bearing. So if two back bearings or two objects back bearings are plotted on a map, then where they will cut, probably that is the position where I am standing. Now how to make sure that I am more accurate in my position estimation, then take the back bearing from third object, and if the line again cuts on the same first crossing of these two back bearings, the third one also cuts at that place, then I am sure that I am having more confidence about my position estimation. So almost this concept, but instead of in 2D, it has been implemented in the 3D with these navigation systems. So what the satellites are doing basically, that they are transmitting their position as well as the other data like timing and other things, and when it is received on the earth by a receiver, then the time taken is calculated and multiplied by the speed of light, and this is how you get the distance of the satellite. And if you get, like in back bearing concept, if you get a bearing from two far apart objects, then you can get the first position estimation. Similarly, in case of these navigation systems, satellite based navigation systems, because we are talking not in 2D but in 3D, so instead of bearing from 2 or range from 2, here you require at least ranges from 3 satellites. And then in order to get the jet position also, you require range from the 4th satellites. So they will be basically cutting or there will each range will basically construct an imaginary sphere, you can think if you wish, and when these 4 spheres will cut, and then you are sure that this is my position on the surface of the earth. So this concept basically was there, and in the form of back bearing concept, that was in 2D. In the case of satellite based navigation system, this is now in 3D. As in this figure, it is shown here that signals from 3 different satellites are coming, and since their ranges are cutting at one location, so as far as my horizontal position is concerned, I am sure that I am standing here. Then there might be some accuracy issues are there, which depends on the signal quality and other things. But if I am getting signals from 20 or 12 satellites simultaneously of different navigation systems or even one navigation systems, then my position estimations is going to be very, very accurate, because all these ranges which we are seeing here is a schematic. They will, if they are cutting at one location, then of course my position estimation is going to be much better. So the basic concepts of satellite positioning are very easy to understand. As I have just explained, it can be demonstrated by taking cardboard figures of 3 satellites to the walls and ceiling of the any room, and there when you draw the or pull a thread from there, then you can have this kind of scenario. Same way the satellites also do. Instead of some strings, you are having signals and ranges are there. So this is how the position estimations are done by the satellite. We will be also going through in much more detail about these, how the positions are estimated and that thing. What basically the more the satellites signals are available to the receiver, better the position is going to be. And that is why it is mentioned that if you are looking for good accurate position, it is always suggested that one should go in open area if it is possible to get more positions, better position. And there are of course some factors will play. If you are in a valley, in a mountainous area, then your sky, open sky is very limited. You may have poor signals, therefore poor position estimation. Or sometimes a little bit, though it is a all weather condition systems, but still if there are very harsh weather is there, sometimes these atmospheric signals, atmospheres can also bring some distortions in position, and because after all data is coming through radio signals that may get disturbed, so the position may also get. So the more basically in this navigation system, as you have seen the brief history and whatever is happening today or currently or in future, that it can be said that more you explain it and the more I don't understand, because things are really getting more sophisticated, or sometimes you can call as more complicated. But on the other side, they are getting more accurate, more quicker, and wide applications. Lot of applications of these navigation systems are coming. So at this point I stop here. Thank you very much.